so that the functions e to the power ax and e to the power minus ax are linearly independent by the help of Wronskian. So by using Wronskian we will prove that the given function e to the power ax and e to the power minus ax, they are linearly independent. We know if the determinant, that means the Wronskian is the determinant of y1, y2 and y1 dash, y2 dash. That means the first derivative of the solution y1 and y2 dash is the first derivative of the solution y2. Here y1 and y2 are the functions or the solutions of the differential equation, and these are the first derivative of the solution, that is y1 dash is the derivative of y1, first derivative of y1, and y2 dash is the first derivative of y2. And if the Wronskian is not equal to 0, then the two solutions or two functions, they are linearly independent. So for linearly independent solutions or for linearly independent functions, the Wronskian is not equal to 0, and if Wronskian is equal to 0, then they are linearly dependent solutions, or the functions are linearly dependent. So in this problem it is given that to show the functions or solution of the differential equation e to the power ax and e to the power minus ax, they are linearly independent. So we will see that the Wronskian is not equal to 0. Here the solution or function y1 is e to the power ax. So the first derivative of the function or solution represented by y and y1 dash is equal to first derivative of e to the power ax with respect to x, that is equal to a e to the power ax. Similarly, the second solution or the second function is given y2 is equal to e to the power minus ax. So the first derivative of the function or solution y2 is y2 dash, or derivative of e to the power minus ax with respect to x is equal to minus a e to the power minus ax. Then we will find out the Wronskian or determinant of y1 y2 and y1 dash y2 dash, as it is given y1 is e to the power ax, y2 is e to the power minus ax, y1 dash is a into e to the power ax, and y2 dash is minus a e to the power minus ax. So you will find out the determinant. If you find out the determinant, as you know, in case of determinant, you multiply e to the power ax with minus a e to the power minus ax. So e to the power ax minus a e to the power minus ax minus the multiplication of a e to the power ax into e to the power minus ax. So e to the power minus ax into a to the power a into e to the power ax. So the multiplication of these two terms will be equal to minus a, and multiplication of these two terms is equal to minus a, because e to the power minus ax plus e to the plus ax, this will be equal to e to the power 0, that is equal to 1. Here also 1. So minus a that is equal to minus 2a. So this shows that the Wronskian is not equal to 0, and if the Wronskian is not equal to 0, then the solutions are linearly independent. So the functions or solutions e to the power ax and e to the power minus ax are linearly independent. Thank you.